Swayam Prabha. Digital India. Educated India.
So, hello everyone. So, we will continue with the rotor spinning system mechanics. So, here what we will discuss the formation of yarn structure. Earlier section we have discussed the twist imparting the rotor spinning. So, twist, how twist is inserted in the rotor spinning. So, here the formation of yarn structure by cyclic aggregation. We will try to understand the term cyclic aggregation. So, rotor yarn is formed by the cyclic aggregation, repeated cyclic aggregation in the rotor group. So, individual and small group of fibers accumulated within the rotor group. So, this small group of fibers are accumulated. Basically, mainly target is the individual fibers are landing on the rotor group one by one, but sometime more than one fibers also land at a time. So, typically our target is to have individual fiber and on the rotor group. This is the rotor group. Now, around the inner rotor circumference to form a ribbon of fiber, that is progressively peeled from the group. So, this is the rotor group. Here these fibers are continuously depositing on rotor group, and then these fibers are progressively peeled off from the rotor group to form yarn. This is the peel off point P. Okay, from the rotor, and simultaneously it is being twisted. Okay. So, here this is twisted. So, one is that peeling off and then it is twisted, and sometime the twist is extended within the rotor groove. So, that is known as the peripheral twist extent, that we have discussed. So, to understand this in a better way, so we have made the some assumptions. So, we need to consider in a greater detail to build up of the fibers in the rotor group to form ribbon, and which is called as cyclic aggregation. So, gradually cyclically the building up of the fibers inside the rotor group is called cyclic aggregation, and then after cyclic aggregation then we have to insert the twist in this ribbon. So, cyclic aggregation, the result is that the ribbon formation. So, let us take this an example here. This is the schematic diagram where P is the peel off point. So, at the start up of the spinning, the count of the ribbon is not necessarily the equal to the yarn count. Okay. So, at this, when the yarn is being formed at the start, so whatever the fiber layers will be taken, that may not exactly the yarn count targeted. So, what we do first, the yarn will be formed when the first circumference of this fiber ribbon is being removed. Okay. The required yarn count is obtained when the initial deposited fibers is removed after a yarn length equal to the circumference of the rotor is produced. So, this yarn will be producing. So, initially that pi dr, that much length will be taken out, then the actual count will be producing, and this is done by cyclic aggregation, that we will discuss. Let us begin by considering removal of the first ribbon layer. For the sake of simplicity, we will ignore the effect of twist contraction. Okay. So, twist contraction effect is eliminated here, and assume that at that moment, okay, the tail end of the CDN, okay, contacts the initial deposit of the ribbon. So, the tail end of the CDN which you are feeding, that will be in contact with the initial deposited fiber ribbon. So, the tail end goes to the rotor group by the centrifugal force that we have discussed, and the peel off point P coincides with the point at which the fibers are entering at the rotor group, that is the assumption. So, fibers are entering at the rotor group at point P, and that is the peel off point, but actually it may not be the case. So, for the simplicity, this is the assumption here for the first layer. A smooth doffing tube nozzle is being used here. So, we are not using the grooved doffing tube nozzle, where it inserts the false twist. Okay. So, false twist effect is not considered here. So, peel off point and the twist insertion point are the same as shown in figure here. So, peel off point and the so here peel off point and the twist insertion point are same. Here beyond that peel off point there is no twist, but if we use the nozzle, that notched nozzle or grouped nozzle, so there the due to the insertion of the false twist, the due to the peripheral twist extent, the twist will also be inserted in this zone. Okay. So, fibers leave the exit of the transport channel, okay, are deposited on the rotor wall. So, that will be deposited on the rotor wall and slides down to the rotor groove. So, from the rotor wall, the fibers are sliding down onto the rotor groove. The point of entry into the rotor groove is likely to be only a short distance from the transport channel exist. So, there will be short distance. We shall therefore take the channel exit as the point of coincidence. So, that is the assumption here. Now, we can see here the F is the transport channel. Here the fiber is deposited at close to point P. Let A be marked on the rotor at that point. So, it is very close to that point, okay, A. So, fibers are deposited directly on the rotor groove, which is close to the peel off point P. Now, figure B, this is the figure B here, then depicts a plane view of inside the rotor. Okay. The tail end of the seed yarn begins to peel off. So, this tail end it begins to peel off the fiber ribbon from the rotor group and inserts twist here. Okay. This is the fiber ribbon here. So, you can see this is a fiber ribbon and the tail end of the CDN is there, it inserts the twist on it. Now, you can see the rotor rotates on the anti-clockwise direction, counterclockwise direction rotor is rotating, and A, the point A where the fibers are depositing, okay, and P point P, these are moves away from point 1. This is 1 is the 0, suppose 0 degree, okay, and here it is a 90 degree, 270, okay, 180 degree and 270 degree. That much we are dividing into 4 equal parts. So, point P and A, they are actually moving away from point 1 and moves towards point B, and the gap y, this is the gap y, is between the pull-up point and the point of exit. Gap y will appear between P and A. So, this is because the ribbon is being peeled from the groove. So, as the ribbon is being peeled from the groove, that will actually generate the gap. The peeling speed is approximately equal to the yarn delivery speed. That is we for our assumption we assume it is equal. Okay. So, peeling speed, that is circumference speed of the peeling point is equal to the delivery point speed. Now, the equation we know that peeling point rotation RPM is the spindle rotation divided by Vd by pi dr. So, for the normal withdrawal, this is the actually peeling point rotation when the rotor is stationary, pi d Vd by pi dr when rotor is stationary, but rotor has got rotation RPM Nr. So, that makes the peeling point is actually rotation is added. So, makes Npr is greater than the Nr, that is for normal withdrawal. We have already discussed. With the rotor moving in the anti-clockwise direction, fibers leaving the transport channel are entering to the rotor groove and forming new fiber layers on the top of the existing layer, okay, existing ribbon of fibers. So, in the counterclockwise direction. Okay. If t is the time taken, okay, for A to move to the point 2, okay, then the gap y we can calculate, y will be t into Vd. So, t is the time. So, this gap y is t Vd and a new layer of fiber at 1/4 of the rotor circumference would have been deposited into the ribbon in the counterclockwise direction. So, this 1/4 rotation, then a new layer of fibers will be deposited. Okay. This is we are talking about the only first revolution. Now, from there as P and A moves to 3 and then to 4. So, P will move first to 3 from 2 to 3, then 3 to 4, okay, and A will also move in this fashion. The Y increases and the length of the new layer being deposited would be increased first to half and then to 3/4 of the rotor circumference. So, this if it is moving at 3, then the half of the rotor circumference, okay, and then if it is moving to 4th, then 3/4 of the rotor circumference. So, new layer will be depositing. So, we are talking about the only the first rotation of the rotor. Now, hence Y max equal to V d by N p, that is the maximum distance we can have up to this point. Now, Y becomes maximum value Y max when P point reaches here again at the point 1. So, that for after full revolution, full one complete revolution, the Y, the difference between the point A and P will be Y max, which will be after one complete revolution. So, Y max is obtained with one complete revolution of P, that is the of the this peeling off point, which means complete one circumference of yarn withdrawal. Now, we can see here the new layer being deposited on anti-clockwise direction meets the peel off point when P reaches 1. P again P will reach 1, then the new layer will be deposited. The depositing fiber goes across the peel off point, okay, and then subsequently into the gap Y max. So, depositing fiber will be actually will cover the gap Y max, because it will keep on depositing. The ribbon along with the newly deposited layer, the initial layer ribbon was there, then on that newly deposited layer will be there, continues to be peeled off from the groove and twisted into the yarn. So, for first layer the actual count we have not received. Now, after that, after first layer of first circumference of removal, then the system will get stabilized. Thus, a new gap begins in the crossover of the newly deposited layer at P. So, again new gap will be created when A reaches 1. So, there was a gap Y max, then after that A is reaching 1.1, this newly deposited layer will have covered Y max. So, Y max was the gap and a second layer will start. So, that is the thing, that A will reach the Y max, okay, the point 1. This means a new tail end of the fiber ribbon would have covered the distance Y max from the first tail end point A. So, that is the total distance covered. During the second rotor rotation, the deposition continues as in the first rotor, and rotation So, fast rotor rotation and the new gap is increased to y max. So, fast rotor rotation we have discussed, and during the second rotor rotation the deposition continues as the fast rotor rotation and new gap increased to y max, again it will increase. However, this time when A reaches 1, a new tail end would have formed and third fiber layer would have started. So, in this point, so that new tail end will form and then third layer will form. So, first layer has gone with the P initial layer, second layer was formed, then third layer would have started. This process is cyclic and the fiber layer aggregation with each rotor rotation, hence this is termed as cyclic aggregation. So, for after each rotation the fibers keeps aggregating and then simultaneously it has been peeled off and twisted. So, this process, dynamic process continues. After a time T r, that is pi dr by V d minutes, the original fiber ribbon plus the fibers layer deposited on the top of it would be peeled off from the rotor group that I have already mentioned. The peel off point P, the exit of the transport channel, and the mark A will again coincide in some point. Okay. Once again it will coincide and the gap behind the peel off point will be y max. There will be N L will be T r multiplied by N p pi dr by y max. Okay. Number of fiber layers accumulated at A. So, there will be number of fibers layers will be accumulated at A, that is known as the back doubling. We will calculate the back doubling, and if there are x f fibers of T f fineness in each layer, then the product N L x f T f should be equal to the yarn count. Okay. That is the yarn count. If there are x f fibers, the thickness of the newly formed fiber ribbon will be tapered, okay, linearly around the rotor circumference. So, this will not be uniform in a number. So, there will be tapered, okay, from the peel off point. So, this is the rotor and fibers will have this type. This is the peel off point, where peel off point the required fiber is reached. So, there will be less and less number of fibers as we go towards the tail end of the ribbon. That is why it is a tapered. As the ribbon continues to be peeled off from the groove, the accumulation of deposited fiber layers will always result correct number of fibers at the peel off point P to produce the required yarn count. So, that is the thing, that is due to cyclic aggregation, always there will be a required number of fibers ultimately at the peel off point. So, from the equation y max equal to V d by N p, N p is the RPM of the peel off point, it can be shown that the commonly used twist Y max on an average in order to form, it is in the form of few millimeter. So, this is the, in order to form the yarn, this Y max will be few millimeter for common twist factor. This means when the depositing layer crosses over P, okay, the individual or group of fibers will bridge the gap behind the peel up point. So, there will be some bridging fibers will be there, and for the gap to be maintained, the twist torque must be sufficient to bind this fiber onto the surface of the forming yarn. So, the bridging fibers effect has to be reduced. If you want to reduce, the twist torque should be maximum, and these bridging fibers actually form the wrapper fibers. Since the main body or core of the yarn is already formed, okay, from the ribbon, these bridging fibers wrap around the yarn body and becomes the wrapper fiber. So, this bridging fibers effect we can reduce by increasing the twist. So, this is the schematic diagram. Here this is the bridging fiber. Okay. So, bridging fiber means which bridges the tail end of the ribbon, okay, with the peel up point, which is in contact with the peel up point. To overcome the resistance of the friction barrier of the spinning thread line to the twist flow to the rotor groove, the doffing tube nozzle can be designed to give the false twist. That is this effect we have already discussed. So, that the twist is flown up to the peel up point, even goes beyond the peel up point. This results the peripheral twist extent or tying in zone in the rotor groove. The ribbon is therefore now partially twisted. So, this is, there will be partially twisted before being peeled off. So, the twist is flown into the peripheral twist extent. Although this reduces the spinning end breakage, here is spinning end breakage, the level of twist required to spin, the disadvantage is that when the deposited layer is now crossing the tying in zone, the peel off point, that is the peel off point, more fibers will incorporate as a wrapper fiber. So, here we can see if we have twist here. So, more number of wrapper fibers will be there, because on the inside the rotor group the twist is inserted and rolling action will take place. Now, this is the twist torque here, and here these are the bridging fiber. Okay, rotor rotates in counterclockwise rotation. Figure shows a bridging fiber that is landed with the leading end, okay, caught in the tying in zone. So, leading end is caught in the tying in zone, and the trailing length lies across the gap. This is a gap where this is the point here, the fibers are being deposited. The twisting torque is in the direction of inserting S twist to the ribbon of the fiber, and the surface fiber body of the yarn is subsequently having twist angle alpha. So, that is alpha twist angle, that is the actual twist, and the breaching fiber will have a twist which is at the beta degree. The fibers slide down the rotor wall and into the rotor groove becomes a bridging fiber, and twist insertion point will catch the leading end. So, this is the leading end and becomes partially wrapped. Okay. this cause the length landing on the peripheral twist extent becomes the wrapped in the z direction, okay, and the twist angle becomes beta. So, here the if you see that yarn effectively yarn twist is in S direction, but that the wrapper fibers are in Z direction. Now, here the severe case also may take place, where the wrapper fibers length is, if it is longer, then it will continue to be there, and the wrapper, it will keep on wrapping just like a winding, and the wrapper angle may be 90 degree, and the extent at a particular zone it will wrap. When the short twisted length is peeled off to the rotor group, the bridging fiber length becomes folded and its trailing end is lifted from the gap, okay, and the tail end of the fiber ribbon formed a catenary. So, that is like it is a this tail end will be like a the floating end of chain, and it will move randomly, okay, like catenary. So, here we can see this is the thing, tail end of the yarn is here, and where the bridging fibers are attaching during the rotor spin. Now, this actually here due to this formation, the belt wrap will be there, which is approximately 90 degree angle, okay, and it will wrap in the S twist direction. So, this is the fiber belt formation will be there, like here it is a belt formation, here there will be belt formation will be there. Fibers of different length will have different catenary, okay, suspension, and therefore, differing the wrapping angle, S wrapping angle. Now, here we can see the photograph. When the yarn length reaches the doffing tube, the reverse twisting, that is Z twisting of the false twist removes S twist not only from the yarn core, but from the trailing length of the wrapper fiber. So, this again the S twist, that false twist will also remove the twist from the wrapper fibers also. However, what was leading end length of the wrapper fiber receives the Z twist and binds together into the yarn. And this figure depicts the Z wrap, belt wrap and S wrap yarn. There are combination of this total during cyclic aggregation. So, these things happen randomly, and with the depending on the gap, depending on the even twist flow. So, this wrap angle may be Z wrap angle, belt wrap angle and S wrap angle. Belt wrap angle, where this is the belt wrap angle, where the wrap angle is approximately 90 degree. So, these are the tracer of the Z, S and wrap different wrap angles. Tracer through the tracer fiber technique, the pictures show the wrap angle, where tracer fibers are shown in the black color. Now, what we will discuss in a general condition, general case for fiber ring formation. once the original fiber ring has completely removed. So, that is one original, we told that one has to remove the original fiber ring, then to get the actual yarn, the rate of arrival of fibers equal to the rate of withdrawal. So, initially the rate was not balanced, but after certain, after one layer removed, then the spinning condition, stable spinning condition is established. This may be further explained that on the assumption that yarn arms make 5 revolutions while rotor makes 4 revolutions. So, we can see here yarn makes, that yarn arm that makes 5 revolution, this is the simple assumption, and rotor makes 4 revolution. What does it mean? That means the peeling of point will actually be advanced, okay, for after 4 revolution of peeling of point. So, after 4 revolution of rotor, the peel of point will make 5 revolution. Now, figure A shows once the fibers are deposited on the rotor, they move at the rotor speed. So, as soon as the fibers are deposited, they will start moving at the rotor's circumference speed, that is there is no slip. We assume there is no slip on the rotor surface, and this may be true because of the centrifugal force in the rotor groove. The yarn forms at point P, that is peel off point, and drawn radially towards O. Immediately it will be drawn and it will be pulled out from the rotor by the navel, the withdrawal tube which is placed at the center. So, yarn moves towards the center, and as P advance relative to the rotor. So, rotor will be moving, but P will advance because of the withdrawal. Okay. The ring of the peeled off surface, again there is no slip. Now, here from the figure A, which shows the stream of fibers entering to the rotor at point E. Okay. At point E, the stream of fibers is entering and a ring is already formed. This is a ring already formed. A seed yarn is introduced through the exit point. A seed yarn is introduced here at exit point O at the center of rotor, that is the center. Here seed yarn is introduced and the yarn arm is allowed to become entangled with the other fibers ring at P. So, this yarn arm when it is coming, this will be actually allowed to entangle at the point P, peel off point. A new layer, okay, that is we can assume it is a layer 0 is just started to be deposited at E. So, new layer is started. After one complete revolution of rotor, the situation becomes, so the rotor has rotated one complete revolution, and by the time the peel off point has reached 1/4. Okay. During this period, the following events occurred. So, one revolution, what happened? A to have complete one revolution, point A, and return to E once again. So, that one complete layer has been deposited. So, rotor is rotating. So, fiber is deposited at point E. So, that is why there will be complete rotation. So, one complete layer will be formed, and P has completed 5/4 revolution. Okay. The P is, because one complete revolution of rotor is there, that means 5/4 revolution will have in the P. So, P has advanced by 1/4 revolution to A. Okay. So, P has completed 5/4 revolution, that is P has advanced 1/4 revolution relative to A, and then 1/4 of the original fiber ring has been peeled off. That is the peeled off. From this point to this point, the fibers are peeled off. So, 1/4 of layer 0 has also been peeled off. This process starting instant is P and past point E. Okay. A new layer, layer 1, earlier it was layer 0, now layer 1 started to form at T1 instant. Okay. After T1, this is T2. So, new layer has started at T1 instant, that passes, that P passes E. Okay. After A had completed 4/5 revolution. Again, so T1 then advance, T1 point then advanced, and the rotor speed 1/5 of the revolution. At the rotor speed 1/5 of the revolution, a gap has opened up behind P. So, P, that is 1/4 by 1/5. So, 1/20th gap has been generated, okay, behind P. Now, for second revolution, we can see here, this is for third revolution, this is for fourth revolution. Okay. These things are happening continuously after every revolution. After 4 revolution, the initial fiber ring is completely removed. So, that is after 5 revolution, 4 revolution, the initial fiber layer is completely removed here. That was the initial fiber layer. We can see here initial fiber layer was shown by the blue color. This is the initial fiber layer. So, first we can show, this is the initial fiber layer is blue color. So, 1/4 is removed after first revolution, 1/4 is removed. So, after second revolution, half of the fibers are removed, third 3/4 is removed, and fourth the complete revolution, complete fiber, the initial deposition is removed. So, after 4 revolution, the initial fiber ring is completely removed. Now, we can see for the 5th revolution, again this thing is there. This is an actual picture here, where the fibers are, the tail ends are tapered. Okay. This is repeating 5th, and for 6th this is the revolution, 7th and 8th. So, we can see for after every revolution, this layer, that ribbon is shifted, but shape of the ribbons are same. This is shifting and it is completing after every 4th revolution. So, a more general case we can arrive when the rotor makes n revolution, while the yarn arm makes small n revolution. So, rotor is making n revolution and yarn arm makes small n revolution is illustrated in the following figure. You can see, now we can see here figure A shows the start of where complete layer, initial layer is there, which is shown by the blue color, and initially what we showed with a simplified assumption, but here what we can see here figure B, it is a generalized case. The situation after the arm made one revolution, that is when P has made one revolution, P has come back here once again, A has made n by n revolution. N is the capital N is the rotor revolution, and n makes the yarn arm revolution. So, n by n revolution A has made, and T0 has also made, this point T0 has also made n by n revolution, and A and T0 lags behind P by n minus n by n, capital N. So, small n minus capital N by n, that much it is actually lagging. Now, similarly, figure C shows the next situation when the rotor has completed one revolution, when point A has moved further by n minus n by n revolution, the complete one revolution, okay, this from this to complete one revolution, then the gap will be this one, n minus n square by n n. By this time P has moved on and led by n minus n by n revolution and causes a second break of occurrence in the fiber ring behind P, but before E. So, it is behind P, but before E, and new layer starts with the leading tip at T1. Okay. When T1 moved n minus n by n revolution with the rotor, and P leads T1 by n minus n square by m n. So, that is the situation here. Now, how do we get? So, n minus n by n minus n minus n by small n. Okay. So, this is the n minus n by n and n minus n by small n. So, we get n minus n square by n n. Okay. Now, figure D shows the next stage, the situation after the rotor has completed two revolution. So, after second revolution again we will get this gap. Figure E shows the situation of rotor has completed n by n revolution. So, and the yarn arm by n minus n by small n by n revolution. So, new gap behind P is n minus n by n, which is maximum value of the single gap and the sum of the two gaps that exist simultaneously. Now, for generalized case we can write here the lead of the ER nerve relative to the rotor is n minus n revolution. N is the rotor arm revolution, okay, and small n is the capital N is the rotor revolution. Number of layers on rotor is n by n minus n. Displacement of each layer forward, okay, of the previous layer, n minus small n minus capital N by small n, that much revolution. Gap behind P after one revolution, that we have seen. Gap behind P after mth revolution. So, m multiplied by n minus n square by mn. So, this is the generalized situation here, and maximum gap behind P is n minus small n minus capital N by small n revolution. So, these are the generalized form for the fiber aggregation and what are the different gaps and the number of revolution of rotor in one cycle, that is n by n minus n, that is the number of revolution made for one in one cycle. So, we will stop here and we will close this topic here, and in next session we will start a new topic. Thank you.